welcome to another video. I am super excited to have you here. Just in case you're seeing my face for the first time, like the very first time in this life. Okay, so my name is Emmanuel and I'm a blockchain developer. And of course, you can see I am currently at Web3bridge. I'm going to be sharing blockchain tips today, basically explaining some concepts that you've probably heard about them, but you maybe do not know how they work, how they function. So sit tight and don't forget to jot things down so you can take things away. Okay, so I'm going to start it from DApps. What is a DApp? Now, a DApp is a decentralized application. The D stands for decentralized. Yeah, it's a decentralized application, and what it does, it works similarly as a normal. When I mean normal, I mean like a Web2 um, application. It works similarly, but it's different in the sense that rather than a back end, a DApp uses smart contracts. Now, it can go from a simple DApp to like a complex DApp, and it could go from maybe just one smart contract to several or multiple smart contracts that are called, like they keep calling each other, like let's say there are 5 smart contracts, and when the first one executes, it calls another smart contract, and in that other smart contract, it calls another smart contract. So it can go from just one smart contract to several smart contracts. So what are the components of a DApp? The very first thing, a DApp has a front end. Now the front end can be built with maybe HTML, CSS, and JavaScript. It could be a web application. It could be a website. It could also be a mobile app. So the front end doesn't necessarily mean that it has to be um, a web front end. It could also be a mobile app. Now the back end is usually consisted of smart contracts, and like I mentioned before, it could go from just one smart contract. It could go as much as multiple smart contracts, complex smart contracts. Another thing is like the data storage. Just like the Web2 applications, most DApps, they store their data off chain. What this means is that they don't, because gas is actually expensive, you don't really write those data that you store to the blockchain. So you usually store it in a decentralized storage, a decentralized data storage system. In some cases, honestly, it could be centralized, but you cannot be doing Web3 and be using a decentralized or a centralized data storage. You can actually, but what's the whole point? So usually they are stored in a decentralized data storage, such as IPFS. Now, when I say data, I mean things like pictures, maybe your NFTs, maybe your music, your audio files, all of those things that you're going to use. You store it off chain. That's what I actually mean. It also uses messaging, um, communication protocols. So things like Whisper, just to be able to connect users on the blockchain. So those kind of things are also used. It could also have providers. Providers are okay. So the simple way I think about it is they enable like the front end communicate with the smart contracts. Now, what are smart contracts? Let's get that cleared up before I proceed. So a smart contract is a piece of code that functions on its own without necessarily requiring a human being to execute them. So when certain preconditions are met, the smart contract functions and executes all the required tasks in it by itself. So that is what a smart contract is. Now, the term smart contract may not really be as the same. A smart contract can be really dumb. A smart contract is just as smart as the person who wrote it. So yeah, don't think about it too much. Now, when I say smart contracts, I mean that these are the codes that have been written by the developer. Now, the blockchain doesn't really interact with the smart contract the way it is. Now, smart contracts can be written in high-level languages like Solidity, Viper, so many of all those languages, but they are usually compiled into bytecodes, and those bytecodes are compiled into opcodes, and they are then sent to the EVM. Now, the EVM is Ethereum Virtual Machine. Think of it as a computer or maybe as a CPU that is able to execute tasks in itself, like it's able to run tasks. So I think that's what an EVM is. But now it is not running just any tasks, it is running smart contracts. It is actually executing smart contract instructions. Remember, I said the smart contracts that are being fed into the EVM, they are not high level language. They are usually bytecodes that have been converted to opcodes. Um, yeah, so I was getting at the front end interacts with the smart contracts, and in some cases there are other tools that are used along the way in a DApp. Remember, we are talking about the DApp. I've talked about the front end, I've talked about smart contracts, I've talked about the providers. Did I? Yes, I think I did. Those are the services that interact with the front end and the smart contract. Example could be providers like Infura, Alchemy. You can run your own node by yourself and do the interaction. But sometimes, if you are a developer and you don't want to go through all of those costs, so you could just use a provider. Now, there is what we call like the graph protocol. The graph protocol allows you to query. It allows you to query exact, very specific. What do I use to explain it? So it allows you to query exact requests. Now, think of it as an API, for example. Usually, if you're trying to consume an API, you can usually just use the get method and you get all the data from the API. Now, the graph uses GraphQL to query specific requests. For example, I want to get data from a school, let's say a school database or something like that. Well, I don't just want to get everything. I want to get specifically about the teachers, and I don't want to get all the information about the teachers. I want to get maybe the teachers that have taught for 5 years, and I don't just want to get all of them. I want to get those ones that teach sciences. So with the graph or the GraphQL is actually used in the graph protocol. It allows you subgraphs also. Subgraphs are used as well. So using subgraphs, I'm able to query those exact data that I need from those particular teachers without getting all the data that I could get as well. So yeah, I've talked about how the blockchain works. Yeah, I also mentioned that the data storage is also needed. Now, that data storage can be IPFS. IPFS is one of the most popular. It could be IPFS, it could be SWAM. Now, those are like decentralized data storages that allow you to store your data in them. And the beautiful thing about decentralized storages is that since they are decentralized, there is no single point of failure. What that means is that your data is being spread across a network, and whenever you require it, you always find nodes that are able to fetch you that data. So there's nothing like server is down, so therefore you cannot get your data. I hope that is clear. If you have any questions, feel free to ask, drop in the comment section, or maybe send me a DM on Twitter, and I'll be more than happy to get back to you. Okay, so I've talked about the EVM, I've talked about smart contracts, I've talked about the apps. So let's go to Solidity itself. Like I mentioned, Solidity is a high-level language that allows you to write smart contracts. Like I said in the last videos, I do write articles as well. So do well to check my blog, because in my articles I explain these things in depth, more than I would explain in a 10 to 15 minutes video. So yeah, do well to check. I would start doing code videos so I could actually code and actually see how these things are used. I hope you've gotten a thing or two from what I've said so far. So before I round up, let me quickly just talk about the tools that are being used to create a smart contract. Or will I say tools, or will I say languages? So yeah, I mentioned Solidity. There is also Viper. There is also Rust. Now, these languages depend on the blockchain. Something like Solidity can be used in any blockchain that uses EVM, but for other blockchains that don't really use the EVM, they would require you to have write a different language altogether, and they'll provide all of those things that you need to write it. So before I go, I want to explain what nodes are. Now, I think some people when they hear nodes in smart contracts or maybe in the blockchain in general, they think is I don't know what they think, but yeah, they don't really get what node is. So, what is a node? Yeah, so a node is simply a computer that is running um, a client of the blockchain. In this case, Ethereum. So, a node is a computer, a physical computer in a particular location that is running the Ethereum client. Now, some Ethereum clients can include example of Ethereum clients that you can run includes Get, that is Geth. So when you run the Ethereum client on your computer, you also run the EVM. So that is what makes your computer a node. Now, what happens is that each node has access to the Ethereum state, and for every thing that goes on in the state, you get to be a part of it. For example, so what is a state? Before I continue, so a state is, I can say a state is like a snapshot of how the blockchain is at a particular point in time. So this could be, it could include everything, including the accounts, the balances, the blocks, that all of the things that are there at that particular time. Now, what happens is that when a smart contract is being introduced into the blockchain, it causes a state change. So what happens is that usually when a smart contract has been compiled to a bytecode and has been compiled to opcodes and has been fed into the blockchain by the developer, it may require, of course, it's going to require the blockchain to run those smart contracts when they are needed. And when they run them, they would actually like be changes. For example, in a smart contract that require you to change ownership of maybe an NFT or change ownership of maybe Ether, that is digital currency, or any other cryptocurrency. By the time it has changed ownership and value, Ether has been deducted from a particular account, you notice that the owner, the first owner is no longer the owner, so there's a new owner and someone else has more money than another person. So it causes a state change. Now, each node has a copy of all of these changes per time. And they don't just have a copy of all of these changes per time, they also decide which of those changes should be the current state of the blockchain. It's particular about a lot of. So I hope you learned a tip or two. I hope you're jotting things down. So now if somebody asks you what is an EVM, you probably know how to respond. Thank you so much for watching. Thank you. I'll see you in the next one. Have a wonderful week.